Here we go. And so I want to welcome everyone to our last class. We should have a little time at the end to discuss what we do over the summer, say, and so forth. But for now, I'm going to focus on the end of year 2 wrap up. And what I've chosen to do is I'm just going to go back in time, go look at what I said we would do, and then we'll take a look at, did we do it? Is the question. So one of the things we can start with is this is a local magazine called Natural Awakenings, and so they have a calendar where they put in events. And so here's the event that we put in, which is us, and I'll just read you what people saw. So it says, today humanity is at a crossroads. Religion is an increasingly irrelevant part of daily life, with growing numbers citing their religious affiliation as none. Western science has determined that after 500 years, it has been studying 5% of the universe and calls the remaining 95% dark. Spirituality and mysticism are for many not any part of daily life, with empty materialism becoming dominant. And ever more people ask, what is the purpose of life? So our intent here is to address these issues through lectures, readings, and guided group discussions. We'll present ancient concepts, cutting-edge theories, speculations, assertions, data, and most of all, thought-provoking ideas for discussion. So that's what we said we were going to do. So the question is, did we do it? Any comments?
I think we made a good attempt.
Yeah.
We tried, yeah.
Oh, I think for sure you did, and opened up so many avenues of thought that one, I never thought about, and two, I just didn't know anyone who could tell me some of the things that you have taught us. I think you've done us a great service.
Yeah, I think you opened up so much for, I feel the same, like the survey class was like such a great opportunity to be, very high up, to cross across all these things. And then we've started, because we've been doing this for 2 years now, drilling down in some of the subjects. And now I think we've all got a base or a foundation from each of what we bring to the table to take it even further. It's been wonderful.
And one of the great things for me is I can now talk to my grandson. He is, because he's studying astrophysics, and I can now talk to him. It's really
Wow.
Thank you.
Oh, that's wonderful.
Sure,
We
that's
should
right.
have him do
Now,
it.
does he want to
just-
give a talk?
Yeah.
I can ask, but I don't think he will. He's pretty shy.
Oh, well, we're easy.
I'm going to do one more thing. I'm going to go over to the syllabus we put together. This is a 2-year-old syllabus. Okay, so here it is. It's starting October 7th of 2020. And we've got this picture here, which Richard Stoddard painted. And this is his abstraction of the Kabbalah. So we see the 10 Sephiroth here. And kind of, what would you call this? Energy,
Like a lightning bolt.
lightning bolt going up and down it.
You made it very bleached out. Yeah. Okay.
So we have this to start, okay, which is, not your standard.
That was a life-changing experience for me to see that painting in person. It's huge. When I first moved to Vermont, about 12 years, 2001, I moved there. And it's something I didn't say anything about Kabbalah or anything, but I counted those horizontal lines. And I said, okay, there's 10 there. That's definitely Kabbalah that he's representing. And then it became clearer with some of his other paintings. But so it was a thrill for me to actually, I've only met him on We couldn't even do Zoom. He doesn't have a good enough connection where he lives in Virginia, but so that was a real, I don't know how to put it.
Yeah.
Progress of a kind for me.
Yeah, the 10, they form nodes of the tree of life. But he did this abstraction of it here, which I personally find very appealing. So let me just go to the next page of our syllabus. And this is a poem called The Tree of Life. I'll just read a little bit of it. Behold, that before the emanations were emanated and the creatures were created, the upper simple light had filled the whole existence, and there was no vacancy, such as an empty air, a hollow, but all was filled with that simple, boundless light. And there was no such part as head or end, but everything was one, simple light, balanced evenly and equally. And so it goes. So here we have a mystic view of what things were like before the creation occurred, before the big bounce or the big bang, whichever one you want to vote for. And so that was number 2. And we did spend time on cosmology in terms of trying to deal with this. And then the next thing we had some quotes here. For example, the view is that the universe actually goes through bounces, big bounces. So each of these things that you see here is a universe, and then it comes together and bounces and creates another universe. Then it comes together and bounces. And what you're missing here is the time scale. The time scale appears to be on the order of at least 10 trillion years. It's inconceivable what that time scale is.
But
So
that is what the Hindus teach. They teach that it's like breathing.
right,
That there's these cycles of expansion and contraction.
and that's where we're seeing modern science, modern cosmology come around to that view. And then there's a little thing we have here on Richard Stoddard, his bio, and then we go into what we're going to cover. So we'll just see, did we do this? The course is designed to run weekly for 1 year, covering 10 subject areas for approximately a month apiece. Online meetings layered to build cumulatively through overlapping but revisiting of subjects and historical figures on higher levels. And the weekly sessions can also be standalone. So I think if you look at these classes, they all are pretty much self-contained. If you just took any one of them, you could have a self-contained exposition. And then
do this part.
what we didn't do was have more times for experiential sessions augmented with meditation and chant, which is something that we've talked about doing, but we didn't do. And then there's recordings that everyone got and so forth. And then here's the rest of it. So that's what we said 2 years ago, we would try and do. So now let me get out of this.
I
And
was so happy when I found that image of Dante's Inferno.
sure. And
Or
then I'm
the
gonna
Divine
go
Comedy as a whole.
here. I'm just going to show you, hold on one sec. This is our website. And so on the website, last week we were closing up with subject 9, which is Labyrinth. Now, all of these, this is the resources tab. So all of these things that you see here have been added to get down to, subject 10, which is the culminating lecture. This is the title we had from a year ago, Parallels and Intersections. But if you look at this, you'll see again and again, I'm talking about Stephen Wolfram. Okay, so just to remind everybody, Stephen Wolfram is a Brit. I honestly don't think he ever graduated from anywhere. He went to like Oxford, and then Caltech asked him to come there to work on a doctorate, which I don't, he went to Caltech, but he was like 20 when he was awarded a MacArthur Prize. So a MacArthur Prize is this MacArthur Foundation awards maybe 40 of these every year, and you're given probably enough money to live on for 5 years to pursue whatever you want to pursue. So they're called genius grants, and they give them out to people in various areas. And he got one of these when he was age 20. And he'd been working in high energy particle physics. And what happened was he got enamored over computers, and in particular over writing software that would allow algebraic and symbolic manipulation of expressions done by a computer. So instead of you trying to evaluate some integral or solve some differential equation, the computer would give you a symbolic representation. And then if you wanted to look at it some more, you could actually have it generate some numbers, put in some numbers and see how it actually looked. But the emphasis was on symbolic manipulation, algebra, and so forth. So he founded a company that's still in existence today. It's probably doing $100 million a year and heading north. And its product is called Mathematica, with the name of the software. It's on release 13 right now. And a lot of the high energy physicists were puzzled because once they saw people like Wolfram get enamored over high energy physics, they would just kind of focus on that for the rest of their careers. And it was unusual for someone to walk away from this and go into computers, no less. Most high energy physicists use computers, but they don't, really think of it the way Wolfram was thinking about it, as is doing symbol manipulation and what this would lead to. So time passed, and Wolfram, is again basically using this company to fund whatever he wants to fund. By the way, there is a search engine called Wolfram Alpha, so you can use that. It's a different sort of search engine than Google, but it'll come back with all kinds of interesting answers to things if you go research it. I've used it, and it's very useful. So Wolfram, maybe 30 years ago now, decided he was going to go back into physics, but he spent all his time with computers, and he just started to conclude that there was a need for a new kind of physics. A new kind of science is what he called it. And it would really be based on algorithms or structures where you would give some data, and the data would be processed by the algorithm in some way to lead to whatever. And so that's what you see here with all these different articles. Is I'm just summarizing here his last 30 years of work. These are things that are published on his website, but they're not going to referee journals to where other physicists can comment on them and say this is good and this is bad and we should publish this, but we shouldn't publish that. Wolfram is saying, too bad. I'm gonna write this up myself, and you can take it or leave it, but this is my sandbox, and I'm going to go play in it. So he starts off with what he called, let me just take this one as an example. You'll see here, there's kind of 4 pictures, 1, 2, 3, 4, left to right. So the leftmost one is what he called a structural model. This would be earth, air, water, fire. And Wolfram would add computer to that, okay? There'd be 5 elements, not 4. So those would be structural. Then we have,
We only see three.
why do we only see three? Because he just wrote three little circles there. That's what he did. I didn't write the article.
Well, I expect you to have an explanation.
No, he just decided to write three little circles.
Okay.
And what happened, we get up to the 1600s, and there's been enough work done in algebra that leads to Newton and Leibniz creating calculus. And so we start to use mathematics as a natural way to describe the world around us, in particular for gravity. And then this leads into, in the 1800s, toward electromagnetism, which just becomes a natural way to describe electromagnetism. And then finally we get up into the, I would say the 1960s, when we started to have computation done with, typically you'd have an algorithm of some sort that would take in something and spew out something, and then that would feed into the next algorithm that would take in that and spew it out to the next one. So there'd be a chain of these things running here, a single chain or a single thread here. And then with we all use computers today, and you'll know that the computers have multiple processor cores on them, so that you have 2, 3, 4 cores. You can do things in parallel. And so that's what he's trying to capture here, is that you can explore alternatives here with different algorithms. Actually, you can run these things in parallel because you have so many processors there. You can just start to assign these things to different processors and they run in parallel. But this is trying to capture the notion in quantum mechanics that you have all of these possible outcomes that describe the world around us. And we actually pick one. There's one path that we pick through this, but we could actually look at all of the different paths. And if we could look at all of the different paths, we'd have this incredible clarity or understanding of the truth of all of these things and the consequences of all of these different paths. So here are the 4 different paradigms that Wolfram was looking at. Now let's see, since I got here, I just realized that I got to get out of this. Hold on a second. Easier said than done. Oh, wait, I see how to do it. Hold on. Here it is. Okay, so this is one, but you see how many of these things he's written. He's been going at this for years, and in particular, he comes up with the notion of space as a network. Okay, that space itself, which is underlying everything, is a network, and this leads to a notion of time and causality, and this is a radically different view than anything that the rest of the physicists have been pursuing. So we're gonna spend some time tonight just looking at some of these ideas. But what it suggests is that underlying everything, if space itself, space and time, are really just these network structures that we'll talk about, then those are best described by mathematics. And people have always wondered, especially in physics, why is mathematics such a natural way to describe these physical phenomena? And what Wolfram is arguing is that it's intrinsic, that the underlying structure of everything is in fact mathematics. It's these algorithms and the information that they process that leads to everything around us. So it's a very, very different view than other people take of these things. And naturally, this leads to him making lots of enemies, which is why he didn't want to waste his time arguing with them. He just said, too bad, I'll do it myself. And he has enough money that no one can do anything. So I want to just do one more thing here.
The world of science is extremely political and economic.
Yeah, I,
You know, a lot of research and, you know, the conclusions even that are arrived at are determined by factors like money
yeah.
and politics.
Yeah, the thing that struck me, this is really me going back to when I was in graduate school, and my office, I was sharing this computer with all these high energy physicists who were, you know, I mean, these guys are just off the charts in terms of like just the stuff they were calculating and doing these Monte Carlo simulations. It was just mind-boggling what they were doing, and they were just cranking this stuff out incredibly fast. And then they'd go over to Geneva, to CERN, where the particle accelerator was, and look at the actual experiments against what they'd calculated, and then come back and iterate again, and so forth. And so it was a special time, because at that point in time, you had a lot of things coming together. There was, you had electromagnetism, which was there, but then you had, the reality is that the atoms are composed of protons and neutrons, and the neutrons have no charge, but the protons are all positively charged. And how in the world, what in the world is holding together these positive charges? Because in electromagnetism, the like charges repulse one another. Well, it turns out if you look at electromagnetism on a very small scale, what is repulsive becomes attractive. In fact, the same thing is true of gravity. What you think is attractive as you get close enough becomes repulsive. So gravity flips as well. So that was the first thing. And this attraction of the protons to one another was called the strong force, because again, electromagnetism is an incredibly powerful force. To overcome it, you needed something that was strong. End of story. Now, you also had these neutrons there. And the neutrons, well, if you took a neutron and just left it in free space, it would decompose into a proton and an electron. And then there was this neutrino that went flying off. So the neutrons themselves would decay. We would look at this as radioactive decay, but it was relatively weak compared to the strong force. So that was why it was called the weak force. These are great names. But again, the weak force, when you get it into the nucleus of the atom, when the protons, when radioactive decay, when a neutron decays into another proton, so you get something with remember, the protons determine the atomic number. So if I all of a sudden add a proton, I'm no longer that element. I'm one element up in the periodic table. I've got an extra proton now. And that weak force isn't weak anymore. It's in the nucleus. And so it's comparable to the strong force, okay? But you have to get in there to go look at this. And so it appeared there was going to be a unification of all of these things. And then, oh, by the way, there was gravity. And gravity had to somehow be picked up in this. And oh, by the way, there was doing this on a very small scale, which is the scale of quantum mechanics. And that appears to be very difficult to come up with anything where you could combine gravity and these electromagnetic forces and the quantum effects, other than to do experiments which would involve starting the universe over again. But that's simply not practical. So they thought they were going to pull everything together 50 years ago, and they just hit the wall. And what came out of this was what we'll see. It was called string theory, which is almost religious, as you'll see. And this is what Ron Cowan, took a really good look at, and led to some amazing observations to show that they were on the right track, but they should step back and and do more observations, in my opinion, and then look at how to put it all together. So the problem there, I think the major wrong turn that occurred here was that they kept focusing on the particles. They're now over 200 odd particles that come out of nuclear physics. But actually, when you look at these particles, there are really only a few particles, like 4, but they all have resonances. They get hit with a lot of energy, and they go up into higher states and create particles that are very short-lived, and then they revert back to what they're doing. So the focus was always on these particles and the fields and the forces that resulted in this. And what they missed here, in my opinion, was the arena, the arena that everything took place in. And this is where Ron came back with this 26 real dimensional space, which was made up of these 8 subspaces of 3 spatial dimensions each and 2 temporal dimensions. A lot of people didn't make the leap to having 2 dimensions for time, but when we looked at this, it was perfectly natural. So, so that was the prologue here. When I was in graduate school, one of the people on my dissertation committee asked me to look at some work by a German called Grossman. And Grossman had come up with what he called exterior calculus, which subsumed all kinds of operations in calculus that are called gradients or divergence or curls and so forth. He had a way that unified all of these things. And so my advisor asked me to look at this, and I looked at it and I realized that all of electromagnetism would be described by this exterior calculus. But I also realized I couldn't find this written down anywhere, which sounds crazy, but that's me. The thing about it was the actions there, just going through and turning the crank with this exterior calculus. There wasn't any physics in it. It was just turning the crank on math. And that told me that, either this was much deeper, this is part of space and time, whatever, but there was something much deeper here. And the fields of electromagnetism were just the result of all this stuff. And that was, 50 years ago when I was doing this. So I ended up, when I linked up with Ron, this was always in the back of my head, was trying to resolve this sort of issue. And what we came up with here was, again, there's 2 10-dimensional subspaces. We seem to live in this one called matter. And then there's something called dark matter. And the main difference is that the matter has an electron associated with it, and the dark matter has no electron. So the dark matter just is made up of these particles called subquarks, whereas the matter has an electron plus the subquarks. So,
and this, I just want to emphasize or ask you to really explain. This is standard physics. This isn't speculative. This isn't.
This came about. There were 2 things that drove this. One was in the early 1960s, Richard Feynman at Caltech decided to try and figure out how he could have gravity, have general relativity to encompass quantum mechanics. And so there's lecture notes. You can buy these on Amazon. They're available. The Feynman lecture notes on gravitons. The particle of a gravitational field is called a graviton, just like a photon is the particle for an electromagnetic field. And so he looked at this, and what's intrinsic to these particles is the notion of spin. So he looked at, what if I had a spin 0 graviton? And he showed it was impossible to come up with a consistent theory It would include quantum mechanics and gravitation. Then he looked at a spin 1 graviton. Was it possible there? No, it was impossible. Then he looked at a spin 2 graviton and he says, wait a moment, now this is possible to come up with a theory that will combine both general relativity, gravitation with quantum mechanics. And he left it there. 6 years later, a guy named Lovelace was looking at these spin 2 gravitons, and he had these things that were oscillating that today we would call strings. And he was trying to figure out the strings really wouldn't behave properly until he started to increase the number of dimensions. And when he kept doing this, when he got up to 26, that was the first smallest number of dimensions where everything worked, where he had a spin 2 graviton and where the strings could all oscillate happily. So the strings are all oscillating in all of these subspaces here. They're dark matter strings. Ron looked at these things, and they're 10 strings for matter, and there are 5 strings for dark matter that make up what we call subquarks. And then we have this electron running around here for matter. And so then over here with matter, we also have, and this is really a key thing, these other 18 dimensions that are compactified, that are conceptually, think of it this way. We suppose we looked at an X, Y, and a Z axis. Let's just look at the X axis. Okay, so the X axis just goes out from some point. Now, these other compactified dimensions, one of them you could think of as just wrapped around the X axis. Okay, it's literally wrapped around it, and you'd have to get up very, very, very close. That's why it's called compactified, to begin to see there's this other axis there that's next to it. And then there's a second one. Remember, there's 2 of these. There's 3 three-dimensional subspaces, or 6 total. And the other one is the first one multiplied by the square root of -1. Now, I have no idea why the square root of -1 is in this, but conceptually, you should think of it this way. Think of a circle, and a circle, as I run around the circle, I have 2 axes, an x-axis and a y-axis. And so if I'm right on the x-axis and the circle is radius 1, then that's where I'm at. If I swing up to the y-axis and I hit 1 up there, then what's different? Well, I'm going to call the y-axis the imaginary axis. So if the x-axis is the real axis and the y-axis is the imaginary axis, then by swinging from x up to y, I've actually rotated by 90 degrees. And when I get up there, the point, which is 1, is actually the square root of -1. That's what the 1 means up there. When I rotate another 90 degrees, I come to -1. And when I rotate another 90 degrees, it comes down to minus the square root of -1, and so forth. So conceptually, you should think of these things as paired, so that I have 3 dimensions that are compactified here for matter. And then I take the other one and multiply it by square root of -1. So it rotates by 90 degrees away from the first one. And so it goes. And similarly for the dark matter. And then finally, there's this final 6-dimensional compactified dimension that synchronizes, that hooks up to the dark matter and the matter subspaces and makes everything interact with one another. And this is what Ron saw that, as we'll get to in a second, a picture of an electron, that the electron has 10 strings wrapped around it. Those are the strings of string theory, but it also is covered with information, and the information is scanning in all of these subspaces, but in particular, it carries its scan out in the compactified subspaces. This is something that people should try and make instruments to go measure. But the compactified subspaces, the scans take place at basically infinite speed. They're not limited by the speed of light. And that's what makes everything synchronized. Everything works together. And the end result is that the information that's there is following a path or a set of rules or a set of algorithms that are, if you will, the right path that you should take. So this picture, is a very powerful picture, and I just pointed out along the way this year that there's several things that come out of this. One is we saw the Kabbalah had 10 nodes in the tree of life. Well, if we look at this, we have 18 compactified dimensions, but we have 8 holes here and the one at the bottom, 8 holes. So what does that mean? Well, we have 3 holes here. So that links up to the 3 holes in the synchronizing one. So that takes care of 3 of the 8 holes. The dark matter, we have 4 holes, so that takes care of another 4 holes out of the 8 holes. And then finally, we have 6 dimensions here, and one of the holes connects 2 of the 6 dimensions. So even though there's 18 dimensions here, there's only 10 independent dimensions. The holes link them all, and that is what the mystics sensed. There were the Jewish Kabbalistic mystics, and they did this again, thousands of years ago. The tree of life, has been there forever. Another thing to notice about this is simply that we had Jesus of Nazareth, who apparently was incarnated, became human, and he therefore was in this matter subspace here, but was clearly linked over here to his soul, which is in the dark matter subspace. So I would say this is the Holy Spirit or the Holy Ghost that's over here that's linked to Jesus here. And then in the higher realm is what he called the Father. So we have 3 different subspaces here, 3 compactified subspaces, which form a trinity, but they're all linked to one another. So they really are one, but linked through these actions that we talked about. And it was an amazing set of observations, that led to this. Over on the dark matter side, we had what we would call spirits or souls. Ron looked at the 7 major chakras, and they apparently are over here, and they link with us in our body. And so these are the things that are immortal, that live forever. Our body doesn't live forever, but the atoms in our body live forever until they decompose into nothing at the end of time. And so the end result of these spirits or souls here is that they don't really have any. They have the notion of evolution, that they clump together, and Ron called them mind forms, that they clump together. And over time, they're carrying out a sentient thought. But what in the world? The only way that they can sense things is by, for example, going into these compactified dimensions and using that to manipulate. They can control the forces that are over here in the matter dimensions, or the forces that are here in the dark matter dimensions. But they don't have eyes, they don't have a sense of taste or anything. They're pure thought that are just linked together with one another. So it's piles and piles of these subquarks that linked up and are actually sentient and evolve over time. And what I argued was that there's so many of these things. Remember, there's 27% of the universe is dark matter and only 5% is matter. So there's over 5 times as much dark matter as matter, and the dark matter has undoubtedly landed on the Earth and on the Sun and on Mercury and all these other planets, and has created these archetypes that influence us here on Earth. That's trying to push this thing to the limits to see what in the world is going on here. Now, what goes with this, let me just try and advance this thing, was there's a different view, which is the view of science, which is we have physics with the most fundamental particles that are there. That leads to chemistry, and then the chemistry leads to biology. And we have something for matter and something for dark matter, but what underlies everything are these algorithms or the information that controls the fields and the forces of all these different particles and fields that are here. And that underlies everything. So it's both space and the information that the information is actually, as Ron observed, in the walls of the compartments of space. The space compartments are the most finest grain description Ron saw of anything. And a space compartment would just hold one subquark or two subquarks at most. And that was it. And the notion of motion there was you would simply hop from one space compartment to the next one to the next one. But the scale of doing this was minuscule. It was inconceivable how small this was. So these are all things that came out of Ron's observations, and we simply are harping here on the structure. And the key thing we saw was there are two time dimensions here, not one but two, which and then what's
Do it on
left
your
over.
cheek?
Go ahead. What?
Like do it on your cheek?
Yeah, do what on my cheek?
That's my wife.
Oh. Hello, hello. So that's where we spent time on this Isaac Asimov story about the last question. And the notion, Asimov's notion was that we would each get uploaded. So our souls would be there forever, but the universe around us, even the black holes, would all disintegrate. Everything would evaporate into nothing. And then there would be no notion of time. But a timeless interval would pass. It probably was trillions of years. No one knows. And then that would lead to everything coming back together and bouncing to create the universe that we're in now. And subsequent to that bounce, it appears then there would finally be this bang that is what people have talked about. So when you take this stuff, you have to push the limits. You have to go and say, is it consistent across all of these different things? And so we had to look at the cosmology of it. We had to look at the anything that you could think of it for astrology. Why does astrology work? The archetypes are probably these mind forms that are on each of these different planets and even stars far away, and that's what is influencing us. The symmetry that we had here, there were 8 subspaces here, each of which had 3 spatial dimensions, and they seem to be paired up. So each of the 8 subspaces has a one that's multiplied by the square root of -1 that's paired with it. Okay, that's what this means. And because there's 8, that's why I kept harping on these things called octonions, which are we have the real numbers, we have the complex numbers, and we have the quaternions and the octonions. So the octonions are the ones that are fundamental to this universe. Doesn't mean they're fundamental to other universes, just means in this universe that they're fundamental. But it suggests what the underlying symmetries or structure is here for our universe. And there were a couple of great mathematicians, a guy named Killing, who was, I think he was Norwegian, and Cartan, who was a French mathematician who was really world class. He did a lot of work with Einstein, trying to help Einstein work through general relativity. And so they discovered that there were these basic symmetry groups that involved rotations and so forth. They were all very basic, but they discovered that there were 5 exceptional groups, okay, that they discovered. So the study of symmetry led to 5 things that were just out of left field, that were not symmetrical at all. And each of these is tied to these octonions in a different way, which we referenced, okay? And so any theory that Wolfram comes up with here is going to have to deal with this sort of underlying symmetry. So that's to be done. You know, we'll see what happens. We talked about these 2 mathematicians, Calabi, who had this description of these manifolds, and Yao, who showed that they existed, gave a proof for this. The end result of this is that there's probably on the order of 10,000 of these Calabi-Yau manifolds. We happen to have 3 of them in our universe, okay? 3 out of the 10,000. So that suggests that on these other bounces that take place, that some of these other Calabi-Yau manifolds are the ones that are going to be intrinsic. Another thing that Ron saw again was he looked at this double slit experiment where we fired electrons at 1 slit or 2 slits. When there was 1 slit, they went right through just the slit, just like you would think. But when there were 2 slits, the electron was scanning. He saw the scans, and what he saw, these 2 physicists, de Broglie and David Bohm, came up with the notion of a pilot wave. So the electron is sending out a pilot wave, which is testing. Is there 1 slit? Is there 2 slits? And when there's 2 slits, it acts like a wave instantaneously. And so it goes. And so any sort of theory that Wolfram comes up with built on these hypergraphs has to include, you know, this type of control mechanism here. And so it goes. Now, another thing, this is what I simply put in here, so we'd have it, about the notion of the Trinity, the Kabbalah with the 10 Sephiroth, and the notion of souls, the chakras, and the nidis that connect the different 7 chakras. Okay, this takes us into...
And, Jesus of Nazareth was said to be an incredible Kabbalist.
Right.
You could, somebody should do this to compile a bunch of his teachings that are really Kabbalistic statements.
Well, Bruce and I will work on that. We'll see what we come up with. So the notion of non-duality here is so we have this matter side of things with some sort of mind that's caught up in the now, and then we have the other side of dark matter, the mind form or the soul, that's, you know, just pure consciousness, pure awareness of what's going on. And so the ability to break down, to have non-dual awareness, okay, that there really is only one awareness, and we showed you there's 26 dimensions that this plays out in, and so it goes. So the thing that I made notice of here was there was a Purusha, which was the witness conscious or pure consciousness in the Indian traditions. Are you familiar with this, Bruce? Purusha, yeah. And so there was the realization of this primordial consciousness that was witnessing, but was kind of disengaged from the entanglements of the ordinary mind. In samsara, which is considered the moksha or vimutti, the release from suffering, and so it goes. So the notion of non-duality, it appears, again, this is from Wikipedia. It appears that again, you're sensing all of the space, all of the reality around you, and that's not simply in the 3 dimensions for space and 1 for time that we live in, but it's all of these dimensions. And you're also sensing all of the possible paths, that all of the possible outcomes there could be there. So you have incredible certainty about what is really going on. In physics, in quantum mechanics, this would be called the wave function, which encompasses all possible outcomes and everywhere. So that there's some linkage there to modern physics. Again, I pulled out some more stuff out of Wikipedia. Here, what we have is non-dual awareness, or the non-duality of Atman and Brahman. And again, this is the interconnectedness of everything, which is dependent upon the non-dual one, or this transcendent reality, all 26 dimensions. Now, one of the things to keep in mind here, we've got all of these things evolved over people not having the instruments and the measurement capabilities, the metrology that modern science has developed. And so what I would hope to have out of all this is that this would suggest ways to go measure things. An obvious thing would be to build some sort of camera that would be able to take a picture of you, and also at the same time show your 7 chakras, okay, and show aspects of them. There'd probably be some modalities, like different shades of light could come through in such a camera. So that's really what is my hidden agenda here, is to get this to be intellectually respectable, so that other people, would want to go follow through on these ideas. And to me, one of the simplest things is the chakras. And there's other what are the things, the other camera that people use, the
to get
Carillion camera, so they see these, yeah. And so that's probably in this in some way. I just don't know what it is, okay? There's only so many hours in a day to go do this. But a common theme here, though, is that when you go into Christianity, when you go into Judaism with the mystics, when you go into Buddhism, or the Sufis, the meditation takes you to this place of non-duality if you work at it hard enough, and then you realize that is indeed what is really going on. And it's a common theme across all of these things for thousands of years. The Yoga Sutras, it just goes on and on.
And it seems that all the mystics are saying more or less the same thing in different ways.
Yeah, we have Plato, who kept talking about shadows on the wall of the cave. Well, why wouldn't those be these mind forms that Ron was talking about? And the other thing that we saw with Jung was this collective unconscious that was everywhere. But the information that Ron saw was on the walls of the compartments of space, space that's all around you. It was covering the electron. It was covering all of these subquarks were covered with this information that was scanning everywhere all the time. So the collective unconscious is everywhere, and there isn't any duality there. So what we argued for in doing this was that there's a bunch of things that have been done. We cited Leadbeater and Besant and their observations at the turn of the last century, and then dark matter came out through cosmology, but it appears that dark matter is all around us. It's in every blade of grass, and in every insect, and anything you could see around you. There's a little bit of dark matter, because remember, there's more than 5 times as much dark matter as there is matter all around us. It just happens that it's very small. It's these subquarks that are there. And so Ron carried out all of these observations on both the matter and the dark matter. Leadbeater and Besant, with the way that they were doing their observations, they actually never saw this dark matter. They only saw matter. So it goes. And then we had a dark energy, which came about by seeing the galaxies all rushing away from one another. And then what that takes us back to what Ron had observed on information and free will, and this information scanning, and the two physicists that we cited, de Broglie and David Bohm, who talked about having a pilot wave that would be the scans that would take place that Ron actually saw. And that led to a self-consistent theory of quantum mechanics. So it isn't the accepted one. So we started off here with Newton having three spatial dimensions and one for time. Well, this is kind of strange, this time dimension, because like, where is it? We live in the now. There's the past, which is receding. There's the future, which is coming up on us. But where in the world is this time dimension? So the way that Ron ended up looking at it was, well, to start with, we have to have time have the dimensions of length. If we have three spatial dimensions, they all have dimensions of meters. So what we have to do is take time and multiply it by the speed of light. Speed of light is meters per second. So now we got meters. Okay, that's great. But the key thing here was then multiplying this by the square root of -1. So time is, if you will, rotated 90 degrees away from the three dimensions that we have. And that leads to giving us this four-dimensional space, and the rest follows from all this. And then the realization that we needed more dimensions than just those. And here's some examples of these 10-string subquarks that Leadbeater and Besant saw. Here's another guy, Babbitt, who went into heavy-duty meditation and saw this. So did John Keeley, and in all likelihood, Nikola Tesla saw this as well. There's indications of that. The dark matter we talked about as holding the galaxies together, because if we just looked at the stars that we could see spinning, they'd all fly apart unless there was more matter there that would gravitationally attract everything. And that led to this notion of dark matter. And the dark energy was pushing everything away and so forth. So I'm going to send this out, but I want to go back now to some of our videos and give you some idea of what in the world we didn't cover here that these physicists were busy going at. And this is touching on what Wolfram was doing.
And this is underlying everything that we were giving examples of.
Right. So I'm going to start here with this one physicist, Lee Smolin, who is not too far from Bruce. He's at Waterloo. And for those that don't know, up until 1914, the town was loaded with Germans, and it was called Berlin. So a little name change took place. But they have a nice Oktoberfest. So here we go. We're going to go to this. And I'm going to have two little short videos by Lee Smolin. Here's the first one.
Space and time are things that we take for granted, but we've been told and we're starting to believe that what Einstein said, that space and time are not quite as they seem, but they're dynamic, they're mobile, they can curve, they can slow, they can expand, and but the two are really unified together, and we need to understand space-time is critical to understand the nature of our universe.
It's the most important question.
Okay, so
What
it's
is
the most,
time? What is space?
okay, even more important than what are the particles and what are the forces. And we want to
I
understand
think
everything.
so. I
So
think
it's some people have thought of it as it's the arena in which all the act of particles and physics play out, but it may be more than that.
the basic division in the subject goes back a long time. It goes back to debates between Newton and his contemporaries, Leibniz and other contemporaries. And the big question is space an arena in which things happen, in which things come on and off? Or is there no arena? Is space just a network of relationships? A way to ask the question is, if the whole universe were moved entirely 10 meters to the left, would it matter? Does it even mean something to say that? Because no relationships would change.
Right.
And Newton said, yes, it is different. And Leibniz said, no, it's even wrong to ask the question because there's no discernible difference between the universe here and the universe 10 meters to the left. And this very question of whether space is a framework, an absolute background, or whether space is an aspect of reality that grows out of a network of relationships, of causality, of change, is the fundamental question, as has been for 400 years.
Okay, so if we're trying to understand the nature of space at this point, we're dealing with different concepts as well. We're dealing with relationships.
Yes.
We're dealing with causation.
Yes.
And so those are very fundamental ideas, but what you're saying is that to understand space, we may have to understand those other two, which may be more fundamental than space itself.
Yes, and indeed, one can take general relativity, and if you ask, what in that sophisticated mathematics is it really asserting about the nature of space and time?
Right.
What it is asserting about space and time is that the most fundamental relationships are relationships of causality. This is the modern way of understanding Einstein's theory of general relativity. And so if you think about the structure, an event happens and light goes out of it. We have these pictures of light cones going out. And if you can travel from that,
as light goes out over time at the speed of light, it covers a greater and greater distance.
greater and greater distance. So you imagine a sphere going out.
Right.
Now, if a later event happens within that sphere, information could have reached there from the first event going at slower than the speed of light. And so there could be a causal relation. There will be a causal relation between the first event and the second.
Right.
If another event is so far away that light could not have gotten there, then there's no causal relation. And the interesting thing is, if you write down a list of all the causal relations between all the events in the universe, you describe the geometry of space-time almost completely.
Oh.
There's still a little bit of information that you have to put in, which is counting, which is how many events take place.
So
they don't have everything.
So whereas the common perception is that we have space, and in the space there are relationships like my chair and your chair, or there are causes that I push your chair and you move a little bit, that is an artificial distinction, that maybe it's the events themselves that create the concept of space.
Yes. Yes.
I mean, that's
and that's not just a metaphor, it's the best way of understanding both the principles and the mathematics of Einstein's theory of general relativity.
Now, this sounds very profound. Are there implications of this that you can say, okay, if that's true, what follows? What would then happen that we can see in observation or learn about our world, or is this just some philosophical idea?
For example, the whole idea of what a black hole is comes from thinking about the causal relations. A horizon is a boundary to what can be causally influenced by what's, quote, inside the black hole. So if you want to really conceive of what a black hole is, you have to think of it in terms of causality and causal relations. The idea of the singularity at the beginning of the universe, that space and time cannot be continued beyond a certain set of events, came from thinking about the causality. This was a kind of revolution in our understanding of general relativity, brought about principally by Roger Penrose in the 1960s.
Okay, so now we have sort of this new concept of space as perhaps an emergent property of relationships and causes an event. Time into it because Einstein,
but time is already in it, because causality is
okay,
time.
because causality is a sequence.
Causality is a sequence.
So what you're saying is that time then is also emergent, because once you have the cause, time is a natural product of that, as opposed to time being something that we flow through.
Yes, if you take that point of view, then causality is the fundamental aspect of time, and our experience of the flow of time is a product of that.
A derivative.
A derivative of that.
Okay. Now, can you keep then space and time? Is that one unit, Einstein's so-called block universe, where every event at a three-dimensional location and a location in time, so a four-dimensional piece, so you can see the whole history of the universe from beginning to end, supposedly, in this four-dimensional block universe where time is a coordinate?
You know, from the point of general relativity, classical general relativity, you can have it both ways. You can think of this block universe picture, which you mentioned, and you can get away with that to a certain extent. When you bring in other questions about how quantum mechanics fits into the whole picture, about how thermodynamics fits into the whole picture, and entropy, I think it gets harder to maintain this block universe picture. And for me, this is one of the profound issues. The issue is time really fundamental, so that it's the one thing that's not emergent? Or is time somehow emergent or a consequence of other things? And of course, we don't know the answer, but different approaches to the fundamental questions about cosmology, about quantum gravity, line up on different sides of those questions. And this is something I've been thinking about myself a great deal, and I've been finding personally, I'm thinking more and more in the direction that time is fundamental, is not emergent.
Differentiated from space?
Yes.
So you are teasing apart space and time?
Because in quantum gravity,
Sounds quite radical.
sure it is, but it's also maybe the most conservative solution to a set of conundrums that we face when we try to bring together quantum theory and gravity, because the other alternative is that time goes away completely. And in the view that time goes away completely and time is, quote, emergent, then one imagines a world, and Julian Barber is the person who's best explicated this idea. The world is nothing but a vast collection of moments with not necessarily any relation amongst them. The relations of time or causality dissolve, and is just disconnected moments. And this does represent a proper interpretation of certain mathematical approaches to quantum gravity. But these approaches, they succeed to a certain extent, and then they fail. They fail for technical reasons. I don't think I have to go into that here. But when a problem confronts, here's an interesting thing about being a theoretical physicist. A lot is a matter of judgment. And when you face a problem where you make technical progress on some aspects and nobody makes technical progress on some other things, there comes a moment when you say, is that over here really a technical problem? Or do we just have a conceptual misunderstanding? Are we conceiving of it the wrong way? And that's why we can't make any technical progress.
That's what you think about time.
That's what I think about time.
Okay, now we're just going to do one more of these. Hold on a second.
For what it's worth, and I've been thinking about this since I was 14, which is 50 years. That's
Right,
what I think. And, you know, astrology is really kind of like the study of time. I think it exists, but we don't conceive of it accurately.
Well, and what we were arguing here was time exists, but it's really different than space. And in fact, we have one time, is the one we're in, where we think it runs forward, but the problem is it appears we have this other time dimension which actually runs backwards to where we're at. So and so it goes. So now,
For me, I think the error is thinking that it's linear.
well, in some sense, it isn't linear, because once all the matter that we see disappears at the end of time, when everything evaporates and spreads out to the far ends of the universe, there's nothing there. And so any notion of time, I mean, if there's nothing that you can point to that's going on, what is time? There's no, there's nothing, just this void, which is going to sit there for trillions of years and come back together to do a bounce. But how long it takes to do that remains to be seen. So here's another thing that Lee Smolin put together.
We have to learn about the meaning of time. This is Lee Smolin. Thank you. We're starting with Jaron, and we're just going to forget about it.
We're going to explain it. We're going to say that this was originally supposed to be a duo with my dear friend Jaron Lanier, who unfortunately couldn't be here. But
Here you are.
here I am.
All right.
Here I am.
Lee Smolin is from the famous, fabulous Perimeter
Institute for
Institute.
Theoretical Physics. And what an act to follow. Now you're all warmed up and you're ready to go from yoga to thinking about the most abstract and most pervasive, the most abstract concept and the most pervasive aspect of our experience, which is time. Here we are. I'm a theoretical physicist. As Moses said, I came to Canada 10 years ago to help start the Perimeter Institute for Theoretical Physics, where we think about the most fundamental aspects of the world. What is space? What is time? What is law? What is matter? And I want to talk to you about the hardest and most interesting of those questions, which is what is time? And my purpose is not to impress you, is not to wow you with some science fiction thing about multi-universes or anything like that. It's to tell you about the questions that we ask. And what I want to communicate by telling you about some of the questions that we're asking these days in science is how the most abstract and fundamental concepts at the root of our thought affect how we think about everyday life. But I'm not going to mention much everyday life. I'm going to try to be evocative and ask you to think, when I mention scientific questions, how the answer to those questions affects you and affects how you think about the most basic things and the most personal things, as well as things like how to make a society that Patri was telling us about. So let's start with the first question. Is time real? Or is it, as many religions and many philosophies teach, an illusion? That's the most important question facing theoretical physics right now. And let's start by asking you guys, can we have a vote? How many people think time is an illusion? And how many people are convinced time is the least illusional thing we know about, is the most real and least illusional thing we know about? Okay, so it's about half and half. Now, the reason why this is an interesting question is that most of us, if you think about it, have a paradoxical relationship with an attitude towards time, because we all live in the moment. We all experience, everything we experience is in a moment, which is one of a succession of moments. Everything we think, everything we feel is in a moment. Every memory is a memory of a moment. Yet, if you think about what's most valuable for you, what you most value, what you most esteem, we have a habit of putting what we most value and what we most esteem outside of time. Mathematical truth is outside of time, is timeless. Morality is outside of time. If you're a believer, God or some conception of God is outside of time. And so the next question, just to take one of those things that we esteem truth, if you believe something is true, is it timeless? Does making something true, 2 + 2 = 4, is that outside of time? Or is it something which is true in the moment of the experience and asking, and always true because it's true in each moment? I'm not going to have you vote on each one of these, but I want you just to think about the question. Now, physicists, what we most esteem is laws of nature. We see our lives as dedicated to the search for laws of nature. So if laws of nature are the most fundamental thing, perhaps if time is an illusion, time emerges from law. Perhaps laws of nature come first, and time is something which emerges, like heat, like light, like so many things which are not really fundamental, that have to do with our experiences, large, big animals in the world. Okay. Or maybe time is the most fundamental thing, and law emerges from time. Maybe the laws of nature are caught in time the way that all of our lives are. And when you think about law, law is this funny thing in which, Patria, I was very inspired, was talking about evolving law in society and innovating and experimenting with law in society. Seeing law in society is something that develops in time. And some of my thinking about laws of nature have come from a collaboration with political philosopher and theorist, the Brazilian philosopher Roberto Mangueira Unger, who I just dropped to drop a name, which is an inspiration for me. But there is a relationship between thinking about law as law in society and law as laws of nature. And you can think about these questions in both respects. Now, one of the most mysterious aspects of time is the future. And we all think about the future. There was the session about aging, which is our concern with our own futures, the concern with the future of the planet, climate change, and so forth. Basic question about the future. Okay. If time isn't real, if you're one of those people who believes that time is an illusion, then what is the future? Is the future already determined? Do you think, when you think about the future, that, are you one of these people who's a fatalist that, well, it's bound, it's all set up, it's bound, what's going to happen is bound to happen, it's already determined? Or is the future open? And I'm speaking as a person, but I'm also speaking as a scientist, as you'll see in a minute. If the future is open, is novelty possible? There's this idea of science explains everything in terms of laws, and how could anything new ever happen? Because things are just, time is just the rearrangement of atoms. Nothing is really happening but atoms moving around, in which case nothing new can ever happen. Most of my scientific colleagues believe something like what I just said. But we see novelty all the time in the evolution of the universe, the appearance of galaxies, stars, planets, life, everything up to including everything that we experience each day is novel in the universe. Is that a real aspect of reality, or is it an illusion? Another way to say that is that if you knew everything it was to know about the present, could you ever be surprised about what would happen in the future? And again, these are questions, I could translate them into the language of mathematical physics, and they would be questions on the forefront of mathematical physics. Talking about law, another question, and I'll just let you ramify this to your personal business, but another question we worry about as cosmologists is, if we take the laws that we know apply to things in the universe, atoms, molecules, elementary particles, do they scale up to explain the whole universe? Or are there new laws which are coming into play at the level of the universe as a whole? And now, just to go into the personal with the same questions, because again, what I'm interested in communicating is how these scientific philosophical questions also ramify for how we think about ourselves and our personal lives. And by that I mean, if there is a scientific revolution that establishes that time is real, or if there's a revolution that establishes that time is an illusion, how we think about our human lives will change. Okay. So part of is time real, is the future open, on aging. And for me, it's not just about living as long as possible, it's what it means to live longer. Do we have more freedom as we get older Or are our lives more constrained as we get older? That's a question about, is the future open? I tried this out on a bunch of 20-some artists once at a gig I had to do, and they didn't know what I was talking about. Okay. On the societal level, what's the wise response to the threats of climate change and other threats that are 50 years, 100 years, 200 years in the future? How do we think about the future? Do we think about the future is open? Okay, all these questions are tied together. Now, a lot of people are turned off to science. And I've asked, as a scientist and as somebody who's very interested in publicizing science and communicating about science, I tried to understand why so many people are turned off to science. And a thing that I've understood is that the picture of the world that science has taught is unattractive. It feels, the universe that physicists describe feels inhospitable to many of us. And one of the reasons is that the picture of nature as made up, as reduced to the interactions of atoms, doesn't leave a place for human meaning, for desire, for pleasure, for intention, for consciousness. And this is this old-fashioned picture that nothing happens in the world except atoms flying around. And if the laws of physics that describe how those atoms fly around and interact are deterministic, as Newton's laws were, okay, then the future is completely determined. Whatever you think you experience about making a choice, it's not really true. You don't really make a choice. It's just those atoms and the chemicals moving around. Free will is impossible. And this used to be the standard picture that physics taught about what was fundamentally true, and no wonder people rejected it. Well, that kind of scientific fatalism is no longer, let alone on personal or philosophical grounds, it's no longer scientifically very convincing. And the reason is that it leaves big questions unanswered. And I want to tell you about some of those questions. The claim is if you know the laws of nature, you can predict the future and everything is determined. Why are certain laws true and not others? You see, physics is undergoing a sea change because we used to think our job was to find out what the laws of nature are. And we're not quite done, but we're pretty far down the line to finding out what the laws of nature are. And another kind of question has reared its head. Oh my God, why are those the laws rather than other laws? We can imagine lots of different laws. Why are the particular laws that our experiments discover are true? And just saying that nature is deterministic doesn't address those questions. Not only that, if everything evolves from earlier states of the world, what began things? The universe started, quote, at the Big Bang, allegedly. It started in some state, in some configuration. What chose that first state of the universe? Again, within the standard framework of physics, there's no way to answer that question. Now, it turns out the story about the explanation of physics running out has been and expressed for a long time. The American philosopher Charles Sanders Peirce, and I'm not going to read the quote, but in the 1890s, he said what I just said. And he went on to say that just to say what the laws of nature are doesn't explain anything, because you have to explain why those are the laws. And he went on to say the only possible way of accounting for, of explaining why certain things are true, why Newton's law is true, why the laws of electricity are true, why the laws of gravity are true, is that they are the result of evolution, which means laws change. And if laws change over cosmological time, then there's a whole other story which we've just begun to explore. How do laws change? What selects the laws? And that's what a lot of my friends in physics and cosmology are starting to grapple with. Now, there are other reasons why the picture is breaking down. Quantum mechanics itself is not deterministic, and quantum mechanics is the most true law we have. And I'm going to go a little bit faster so I have good time at the end. Talk about determinism is fine, but determinism only applies to little isolated systems. It doesn't apply to the whole universe. But nothing everything influences everything else. Everything is connected to everything else. So if you think there are chains of causes that explain everything, you get to the scale of the whole universe, but maybe, as Peirce said, laws are evolving on the scale of the whole universe. So a new viewpoint is developing. And I don't claim that this new viewpoint is true. I don't claim it's compelling, but it's radically different. It's a radically different view of what nature is and how nature works. And it applies a radically different way of thinking about the hospitality of the universe and how we fit into it. Steve Weinberg used to say that the more we know about the universe, the more boring it is, the more, and he didn't say it, but he meant inhospitable. The more foreign to us, the more alienated from us it seems to be. But that's on the old way of thinking about physics is made from absolute laws, which are timeless and deterministic and so forth. In this new viewpoint, time is real. The flow of time is the most true thing we know. I used to believe that time was an illusion, as do many of my colleagues. Now I think that time is the most real thing we know. Everything else emerges in time, including law, which means that the future really is open. Novelty is real, it happens all the time, and a large part of being human is the ability to invent things that are not just seem new, not just faking new, but are genuinely new. That's a lot of what we are about as human beings. The laws, even the laws of nature, may evolve with the universe. The future is open. The future has yet to be made. And it's not like it's easy to change things. You know, some people in politics talk about, sometimes they talk about turning the rudder to turn the ship of politics. And then people with a little more experience in politics talk about turning the rudder that turns the rudder that turns the ship. Okay. It's not that it's slam bang easy to influence the future, but if you believe the future is open, you can be optimistic about our potential to thrive in the world as it's growing in the future. Now, I should say that most of my physics colleagues who are at the frontiers of physics and cosmology still think that time is an illusion. They think there are an infinite number of universes, they all coexist timelessly, okay? And everything that's true or valuable or lovable about ourself, our existence in our universe is just an accident. I don't think so. I think that there is a possibility of the development of a scientific theory along the lines I've just been describing. But I'm not here to convince you that that is the right scientific theory. I'm here just, and I hope I've given you a taste of this, to communicate that it matters what science discovers. It matters for everything from how we think about political organization to how we think about the far future of our society to how we think about the most personal questions about the future. So is time real or is time an illusion? The most important thing that we can do as scientists is find out which makes more sense, which fits the evidence better, and I hope I've gotten you interested enough to follow this story. Thank you very much.
So there you have, Lee Simone's view. The picture that Ron developed, we're showing time, 2 dimensions of time.
But I did like the last sentence. Imagination is essential.
I have to be able to shut this thing off. The picture that Ron developed there, showing those 2 dimensions of time, suggests that time is indeed there. It's special, it's real, it's not an illusion. And in fact, it suggests that you could probably, if you were smart enough and worked at this long enough, build a time machine, something that would allow you to step out of time and step back into time at some other point. That's what's implicit in what was going on there. Now I'm going to try and do one more thing. Oops, wait on. I just did myself in. I see what I did wrong. The thing that I wanted to do was just do a short video on what Stephen Wolfram, as we've been kind of walking around what he's saying and so forth. And that's really, I feel we haven't really done justice to this. So let me just try and resurrect. I just lost it just now. There's a short video here that gives you just a taste of what he means by this new sort of science. And you'll just have to bear with me while we pull the thing up. But as you can see, the work by people like Lee Smolin is really what's dealing with the foundations here, and that's really what Ron was dealing with, but it's complemented by his observations. Okay, he has observations that other people don't have access to, which makes them that much more powerful. Of course, people dispute his observations because they say, well, you just looked at it and you saw it, but the reality is we all see these things, and if you would work at it and meditate the way that Ron did, then you would see it too, or you would refine Ron's observations, that much more. So anyway, I'm just trying to get this thing to load. The problem with this is that we have a large number of these things. Here we go. It's loading now. Okay.
Well, I'm philosophically in favor of time being real. Whether it is or not, I don't know enough to say, but it just seems to me it's what allows all of creation to happen. Whether it's divine, whether it's on a universal scale, or it's our smaller scale creation, it's what allows everything to unfold. It's what allows our relationships to unfold. It's what allows our character to develop if we see things in a linear sense.
Yeah, one of the things I forgot to mention, I just touched on this when I said that that space is made up of these compartments. So space is quantized into these discrete space compartments. Well, if that's the case, then any theory that you develop, such a string theory, has to be able to account for the behavior of the space compartments as well. And that by itself is a non-trivial thing, or that's why I think what Wolfram is doing offers the best hope, because it naturally includes the behavior of the space compartments themselves, dealing with these different particles and fields that are out there. So let's see, we're almost loaded. You can see all these things again on our, this is the science tab of the website. Here we go. So this one here, why you've never heard of Wolfram physics, is because he's not playing the game that other people do, but he is publishing large amounts of stuff, and it's all accessible. So I'm going to just give you here, what are the basic concepts that you get out of his notion of physics.
Hi, Yuri. Today I am going to dive right into Wolfram physics. If you've never heard of Stephen Wolfram or his team's project to find the fundamental theory of physics, don't worry. Think of it like this. I'm going to dive right into the fundamental structure of the universe. And, well, you might not believe that the words simple and physics can go together, but I'm going to keep it simple. This deep dive is going to raise more questions than answers, but that's okay. I'll be looking into those questions and looking for answers in future episodes. So without further ado, here's the universe. Well, I told you I was going to keep it simple, didn't I? Actually, this isn't the universe so much as one possible universe. And it's that universe right back at the beginning of time before it explodes into, well, we'll soon see what it explodes into. This universe consists of 3 nodes connected by 2 edges. The nodes are just points. There's 1 node on the left and there are 2 on the right, up here, down here. The edges are just lines between the nodes. One edge goes from the node on the left to the node that's upper right here, and the other edge goes from the node on the left to the node that's at the lower right side here. Each edge has a direction, which is indicated by the arrowhead. A set of nodes and edges like this is called a graph. It's a confusing term. When I talk about a graph, I'm not talking about a plot of y against x. Rather, when I'm talking about a graph, I'm talking about a set of nodes and edges just like this. And that's it. That's all there is to our universe. Just 3 nodes and 2 edges. Simple. This universe, however, doesn't stay simple for long. There's one last concept that I want to bring in here. I've talked about nodes, edges, and graphs. Now I want to talk about rules. Rules are like the laws of physics. They determine how the universe changes over time. Actually, let me restate that. If Stephen Wolfram is right, then rules aren't just like the laws of physics. Rules are the laws of physics. So let's apply a simple rule to our universe. The rule has 2 steps. Step 1 is to find edges that match the rule. In the rule that I'm going to apply, that means finding 2 edges that come from the same node. In the case of our simple universe, matching the edges is easy. There are only 2 edges, and they do come from the same node. I'll highlight them in blue to show that we found our match. Step 2 is to evolve the matched edges according to the rule. In the rule that I'm going to apply, that means deleting one of the 2 edges, creating a new node, and creating a new edge from each of the 3 existing nodes to the new node. Okay, let me run through that more slowly. First, we need to delete one of the 2 edges. I've chosen the lower of the 2 matched edges, and I've highlighted it in red to indicate that it's about to be deleted. Nothing's going to happen to the other matched edge, so I've turned it white again. Next, we need to create a new node. Now, I could have put it anywhere, but for now I placed it here, right at the center of the 3 existing nodes. Finally, we need to create a new edge from each of the 3 existing nodes to the new node. I've highlighted these new edges in green. So this is one, this is the second, and this is the third. As ever with edges, their direction matters. They're from the existing nodes to the new node. So the green arrows all point towards the new node in the middle there. So here's what the graph looks like after the rule has been applied. I've deleted the red edge and I've turned the green edges white. So we now have 4 nodes and 4 edges. Still pretty simple. It really doesn't matter where in space I position the nodes and the edges. Why not? Because these nodes and edges aren't in space. These nodes and edges are space. I'll say more about this in a future post. Prepare for your mind to be blown. For now, I'm going to reposition the nodes so that they're more spread out, which will just make the graph easier on the eyes. And that's it. Now you know everything you need to know to work out how this universe evolves. 3 nodes, 2 edges, 1 rule. So let's apply the rule again. Step 1, remember, is to find 2 edges that come from the same node. There's still only 1 pair of edges in our universe that match these criteria, the ones highlighted in blue. Step 2 is, again, to delete one of the 2 matched edges. I've highlighted it in red, the one that I've chosen to delete. And then create a new node and 3 new edges. Again, I've highlighted them in green. Those new edges running from the 3 matched nodes to the new node. So that leaves the universe looking like this. Again, I'm just going to reposition the nodes just so that they're spread out more. And so we've applied the rule twice now. If we apply the rule over and over, something curious happens. So what's happening here is that I'm applying the rule again and again. Exactly the same as I showed you the first time. I'm just choosing the edges to match. Sometimes there are multiple possible matches that I can choose. And I'm deleting one of those edges, creating a new node in the middle of the 3 existing nodes and creating 3 new edges in exactly the same way as I've showed you already. So our simple universe is starting to become complex. The more times we apply the rule, the more complex the universe becomes. This seems strange. We'll see that after only a couple of 100 iterations, the universe will already have structure, clusters of tightly connected nodes that are only loosely connected with each other. How can such a complex universe arise from such a simple rule? And here's the crucial question. Might a universe as complex as our own arise from a similarly simple rule? As I say, that's more questions than answers. Make sure you're subscribed to The Last Theory to join me in my exploration of Wolfram physics, and I'm hoping that in future episodes, I'll be able to answer some of those questions. Thanks for listening to The Last Theory. Join me.
Okay, so I'm just trying to give you a taste of what Wolfram is doing. Remember, again, if we're dealing with something with 26 dimensions, at every point, we need 26 numbers that describe what's going on. So you could imagine taking the graph that he had, but adding 26 numbers, not 2 numbers, and you start to appreciate, you know, it can get really complicated in a big rush, and who knows where it's going to lead. So with that, why don't we want to know at this point, what do people want to try and do for the summer? We had heard last time about astrology, and we heard of, I've just exposed some more stuff on Wolfram. We could do a little bit of each of those for the rest of the summer. What do people want to do? Any comments? Or do you want to take the summer off?
Bruce looks stricken. Are you okay, Bruce?
Yeah, I'm okay. I mean, I'm still thinking about where does the path of meditation lead to when it happens? It's so different than intellectual ideas. It's one of my quandaries about how the East looks at things and how the West looks at things. The West is very into concepts, and the East is very into kind of like direct realization, which is entirely intuitive.
Right.
I don't know, it just,
No, that's a good point. We should try and address that.
yeah, it's like, yeah.
It shouldn't just be a Western balance. It should be in particular, I was looking at doing Hindu astrology, which I think might encompass some of this. And also just the harmonics.
Well,
that
Hindu
go with
astrology is almost entirely harmonics, which is something that Bart is especially interested in. So we've been thinking about ways that these things might come together more. That's sort of what we're hoping to discover.
Mm-hmm. Yeah, well, I kind of like maybe the sort of unexpected, the Wolfram stuff and astrology to me don't feel like they go together, but that's what makes them interesting, to sort of counterbalance them. That kind of is an interesting, I don't know, I kind of like that original suggestion. The one thing that I wanted to comment about, trying to think who the word love, and Bruce, you've introduced so much for us on this topic of describing love and love mind. And I heard somebody talking about love, and they described it as love is not, again, like Bruce, you say, it's not about duality. And love is, there's no love. We as Westerners might say love and hate, but love doesn't have an opposite. It doesn't have the counter. And that was like, so I could not have gotten that had I not been in this class. And I'm like, wow, that is so neat to think love is just into itself. And there was more that I can't grab right now, but I would like to continue also on trying to understand the mind more too, which meditation does have, that is about the mind. And that also is, I think, how like the thing that you're really fascinated with Bart, what you and Ron have been focusing on, with what you can see with these, 26 dimensions and all of that. And it feels like meditation that's the pathway to that kind of ability to see those things. And I don't know why are you laughing, Bruce.
Well, that's what it's like, that's all.
The only reason why I'm suggesting to include, there's a lot more material now on what Wolfram's doing out there, as you saw this one guy putting together this stuff. But it stresses our thinking, okay? If we have kind of two different ways of talking about something, and these are like so different, okay?
Yeah.
It'll force us to come through and think through each of them more clearly is the whole point in doing it.
Mm-hmm. I like that. I really like it. When I first heard it, I thought, well, that's kind of crazy. And then I thought, no, it's exactly why it's crazy. It's because of what you just said.
And they might connect more than we think,
Exactly, Marjorie. I would agree.
I kind of think they will, but that's me.
Yeah, and again, we went through the Yoga Sutras to some level, so you can see this is 2 millennia at least, older than that. There's nothing new here.
Yeah,
I've been thinking about all of this for a long time.
I was moved by the thing when you showed the your summary of Aleph talks that you wrote so long ago. I don't recall seeing that before, and I was like, really, I love that. I thought that was excellent.
We were down. That's because we're so much down in the weeds. You miss where the trees are.
Yeah.
I mean, I'm like, that is like so amazing, but maybe it's because we've been doing this for 2 years. I could relate to it all. I could it meant something to me today to see that.
Sure.
Well, it's on the website, but maybe we should start off each class or end up each class reviewing it, because it
Yeah,
kind of help orient us to,
it does. Yeah, I thought it was really great to see that you had that concept from the very beginning. You put that together from, day one. Or
there is a structure.
early in it.
May not seem like it, but
Yeah, but you can see over the 2 years, the content has changed, but it really hasn't changed the framework that we're talking about. The
Yeah.
content is very different.
but I just think it's going deeper and we're finding deeper illustrations. And it's wonderful to discover that all these videos exist that
Yeah, yeah.
are
Well, Barbara and I-
what we're talking about, but we didn't have to reinvent the wheel over and over again to do it all.
Yeah, yeah. Well, Barbara and I are, I think we are like amazed sometimes at the conversations we have that we would have never had together if we
Yeah.
hadn't been in this class.
True, very true. Bruce, how could you help us understand the mechanism of meditation better?
The mechanism of meditation.
The mechanism.
How do you connect with it on a deeper level? What is it that makes it so important to us as a vehicle for understanding and enlightenment?
I can't hear you well enough.
Do you meditate? Do you meditate?
Meditation?
Yeah.
He's asking about, can you talk about the mechanism of it
I think part of it
and
is,
how it changes your perception?
yeah, Barbara, part of it is, I run into this with people that just have trouble. There's so much noise around them. They're just caught up with the here and now and the what's on TV and the internet and they just can't calm down. And then I get other people that like calm down and fall asleep.
And just tune everything out.
Yeah, so there's, Bruce, what would you say?
Well, what happens, I mean, sometimes a lot of people just can't get there, but when you're actually able to get there, all that disappears. The mind is knowable. It's so deep it goes forever. So it's not like you can comprehend it totally, but the comprehension is already reality. It's already there, and you have access to it. And it's different, really different. It's not like thinking at all. In fact, it doesn't involve thinking. So it's just a very different dimension. But there's certain qualities of it that are very vivid. I think one of the qualities that is sort of missing that most people don't get is that there's actually union everywhere. It comes from the love reality understanding is that you're not actually separate from the universe. Whereas in classical Buddhism, they talk about duality is where there's a self and you think there's yourself, you can't see it, but there's a self and there's another other. But in fact, when you get into deeper meditation, that disappears. What you see automatically is a union and reality of dimensions that go forever. And at the same time, it's all about a love mind or heart mind. And the mind is vastly capable of enormous compassion. And this is basically what Buddhism talks about. Basically, the view in Buddhism is that your mind is already pure. All you have to do is find it. Whereas in the Middle East, you're a born sinner. I mean, in terms of Buddhism, it's unbelievably stupid. But, you know, I don't know, it's just a different understanding of moment to moment. That's different.
Thanks, Bruce.
And that, yeah, Barbara, that's why that picture of 26 dimensions is so deceptive. It's a metaphor, but what Bruce is talking about is the actual experience of that and how
Yeah.
rich that is. Okay, it's not a toy. It's
Gotcha.
incredibly deep. So
Yeah, it has different understandings of the levels of understanding the deeper realities arise in the mind spontaneously and instantly.
And-
There's no, it's not like thinking at all.
and the fact that you've had literally billions of years to develop this. Okay, that's where there's an evolution of all of this.
Yeah, but the other side of that is that reality of forever is already reality in your own mind. Like it's
Right.
not separate. And but it manifests in its own spectacular way, which is not thinking, of course, but it's all there. Like everyone has that. Everyone has millions of years of reincarnations into different lifetimes. And that wisdom is already your reality, but you just don't have access to it. But when you do, it's instantly there. So it's more like that sort of thing.
Hmm.
Yeah.
That's Judith and Bud. Anything you want to chime in on? You're muted, Judith. Wait.
You muted me. I'm game for all of it.
Okay.
Good idea.
Like your attitude, Jim. Jim, like it very much.
Okay, Bud, anything?
So I was thinking about a retreat in New London, hybrid on compassionate communication. I'm working with Pan Vera, and he fronted for Marshall Rosenberg, and that would give us a common language.
Well, that's really
Do
interesting.
you have a date?
Nope.
Could we participate virtually?
Yeah, by Zoom. Could we-
I think yes. Pan has been the last one I was on with Pan. It was virtual. I'd like to start in person because I'm an experiential learner, so that has a much greater impact on me. But it can work virtually too. And then it's like learning any new language. You know, once you learn it, you have to practice it. So then we need to have practice sessions every couple of weeks, and so that when the need arises, we respond automatically instead of having to think about it.
Mhm.
Okay,
They started something like this years ago at the Unitarian Church, and it was very good. There's a lot, our church in Westport, and there's a lot of really good materials have been produced by these folk, Marshall Rosenberg and his people.
Well, Pan actually fronted for Marshall Rosenberg. In fact, I was hoping he might kind of take Marshall Rosenberg's place.
Oh, wow.
okay.
We need somebody. We need a peacemaker,
Yeah.
as well as a pacemaker.
Yeah, and no automatic weapons either. Yeah.
Good, but
I don't know. I'm pretty good at shooting my mouth off.
Right. I understand. Okay.
Speaking of brick and mortar, we're looking for a place to have a real labyrinth walk. We're looking at June 25th, by the way. We've been back and forth, and we wanted to do it at the Unitarian Church in Westport again, and they have something else going on, so they said no. So we're looking for a yoga studio or something like that that's large enough for the 26-foot canvas that we have, the canvas.
Yeah,
It's
there's
really like a
places,
large mandala that you walk.
yeah, we had a very nice place, but it's only 20 feet across.
Oh, wow. Wow.
So we're looking for other possibilities, but that could be, and the nonviolent communication folks have a labyrinth tool too. That I think it needs one modification and it'll be perfect, but it's good the way it is. But that's an interesting workshop tool. I forget what they call it, but it's something, it's some kind of an NVC labyrinth that is, very effective.
Sounds neat. I saw something interesting on the internet. I stumbled upon, there's an island they call Finger Island, and it looks like a complete labyrinth. And it's all stone walls where people have, they don't live on this island, but they grow fruit trees in different types. And the way to keep them separated is they made this enormous labyrinth, which they call a fingerprint. And it's an entire island. It's fascinating. Again, you have to wonder, like, how these things are all related.
Right.
Yeah, Cheryl, could you just send that over as an email and I'll circulate it to everybody?
Sure.
A link,
Yeah, I'll be happy to.
yeah.
Thank
Okay,
you.
I want to thank everybody for participating, and we'll
We'll stay in touch.
we'll do something starting next week for the summer, and just watch your emails and you'll see what it is.
And so can we ask, do you want a week or two off, you guys?
Do we-
Do we
do
want a
we-
week or two off?
Or 3 or 4, whatever.
I'm actually okay, I mean, I know, it sounds, I mean, do you want a week or two off, I mean, we're
We're
coming
showing
up.
up, we keep showing up. So I think the answer is no.
I mean, I'm happy. I think the problem is, wait, when is the 4th of July though? That's always,
It gives us a certain rhythm, to the week for,
Yeah.
for us.
I,
I'm trying to think of ways that we can work in. Maybe we could work in a meditation piece. I think to really understand what Bruce understands, if we wanted more of that, it's experiential.
Mhm.
I would love that. I mean, I've meditated on and off, and it seems like I can get to a point, but I feel stuck somehow. Does that make any sense, Bruce?
Yes.
yeah, we'll try and sort this out offline, what we could do to try and, I mean, there is this whole business, it's a commercial business called transcendental meditation. Okay, which is a way to go approach it, but it's not the only way. So
I think a lot of people benefit from either guided meditations or active meditations. And walking a labyrinth is kind of both,
Mm.
but it's very much an active meditation. It can be really hard to just sit and think of nothing. So it helps to have something that clear. But rowing, rowing on a rowing machine or rowing a boat, that can become a meditation. If you do it the right way, if you're in the right kind of state, a kind of a trance state. And I don't know, I learned to do astrology as an active meditation. I'm in and out of trance.
Mhm.
When I'm looking at a chart, it's a mandala. And I don't know what I'm going to say before I say it. I study it, I prepare. I spend like 2 hours preparing for a 90-minute session with the person. I don't have it all rehearsed. But as I said, I'm grounded in preparation. I will read from books and things like that to pursue the ideas that I have, and I might make some notes. But then I'm in an altered state when I'm actually talking with the person. As I said, I don't know what I'm going to say before I say it. At some point, there's always some message for me. And I say, oh, that's good. I should write that down. Because it's not something that I consciously knew or really brought to the table. But I've learned to look for those in every session. So that's an active meditation. And there are several different types. Some people are just more inclined to that style, or you may benefit from starting that way and then transition into more silent meditation.
Yeah, for me, walking meditation seems to be easier for me, like walking the labyrinth or
Right.
just walking around my block. But the problem with that is, or even my house, if I walk around it, is people talk to me and I can't answer them. I don't know what they're saying. And I've zoned out.
Right,
Sure.
right.
Well, my experience with walking meditation is that, like when you're meditating like 12 hours a day for 3 months or something like that, you're extremely focused and very, and what happens is that when you're doing the sitting meditation, if you do the walking meditation before, it adds a lot of power and capability into the walking meditation.
Mhm.
But it's a very simple meditation. You just walk watching the bottom of your feet.
Oh,
So but when you do that, like it,
Really like feel the whole contact of your,
uh,
in the ways that I was taught, it's usually done kind of in slow motion. And you just want you to be fully aware of the act of walking and not thinking while you're walking.
right.
yeah.
Yeah. Anyway, it's a very powerful way of getting more out of the sitting meditation. It's been my experience with it.
Sure.
I never-
So Bruce, have you done meditations 12 hours a day for 3 months? Have
Yeah.
you- is that something you've experienced?
Yeah.
It would be really interesting to just hear a little bit of your journey, your meditation journey of those kind of things, just to, I don't know anybody that's done that. That's like an extraordinary thing to do.
Yeah, well, what happens is that you get vividly clear and lots of energy, and your mind doesn't miss a thing. All the verbalization is gone, everything. So you notice everything all the time with vivid clarity and so on. So it's really an incredibly good experience.
Hmm. Was it hard to do? Like, could you just start doing it and you just went right into it, or did it build through your practice and your journey?
Well, the biggest thing is I had a very good meditation instructor,
Mm-hmm.
and he was very good at leading into it, what to watch for and so on. But that 3-month retreat was quite a few years before I had my major breakthrough, which is when it all disappeared. I mean, there's basically a fundamental reality that everyone has, because you're so ancient. You had thousands and thousands and thousands of lifetimes. All the wisdom, all the understanding that you gain through all those many, many lifetimes is already there. And it's already knowledgeable of the universe and love and compassion and all that. And that becomes who you really are, which is what you've been all along. What you think you are now is isn't really there compared to that.
Mm,
So it's sort of like that. But as I was saying before, the biggest component of it is this incredibly vast compassion and love mind that's just already reality.
Mm.
Everyone has that. It's really kind of strange. And you get to the place where you can see that everyone has it.
mhm,
So it changes the universe entirely.
mm. What's
know.
the thing that makes me think there's a relatedness is when people talk about the Akashic records, which is the total recording of everything that's ever happened in the universe. Meaning that it's all there again, sort of the same
Well,
same
yeah,
way.
but what you
A
find
different
out
way
is
of saying.
what you find out is that you've been in union with it all along.
Yeah,
It's not separate.
yeah, yeah, cool.
So with that, I propose we call it a night. I
Okay.
just looked at the time. And watch your emails. We'll send out a notice for next week, and
Okay.
it will be a new link though, new link. Okay. Bye-bye.
Okay.
Bye.
Good night.
Good night.
It won't be that long.